And as long as I do that, I have met the minimum requirement of what I need to go over, okay? On the calendar, it says that I'm gonna go over 7.10 and 7.12. That's just extra. So if we don't get to it, like we don't, I will post the solutions online, but you guys won't get any instruction. Because it's just extra practice, that's all it really is, okay? So if you guys can work your way through this, real quick, just in case you're looking at this and you're already confused. Does anyone know how to interpret f of 1 equals 2? What does that technically mean? Or what's another way you can interpret that, Barbara?
1, 2.
Yeah, the coordinate 1, 2. X is 1, y is 2. Okay, that is in function notation form. Because remember, what are you guys used to seeing inside the parentheses? What's usually here? X, right? So if you see a number here, that's saying X is 1. That's all it's saying. So this is actually the coordinate 1, 2. This is the coordinate 5, 10, almost my height. This is the coordinate 10, 8, okay?
You want them all to be in standard form?
You need the equation in standard form, so yeah. Go through that process. If you don't remember what that process is, I recommend you look at your notes. And we modeled this process in example 7.4.4. Okay, so if you're like, I don't remember how to do this, I'm letting you know, I probably should figure that out. The test is on Tuesday. And then you might want to refer to 7.4.4. It's that process, okay? I'm going to tell you, the numbers on these are bad. They're not whole numbers. Okay, they're bad. And they're not even cube fractions. They're all bricks.
So decimals?
Yes. Okay, so you should probably write your answers
Fractions.
in fractions.
Do we use the form AX squared plus?
That's what your notes indicate. Yep. You gotta do that for all 3 points. So in your notes, 7.4.4, that process we did is the same process here.
Oh, wow, 100.
Tina, I'm gonna check this piece of paper with the, how many candy cans I need or whatever, because I'm assuming you're gonna give me a new one.
Yeah.
By the way, guys, say hi to Tina. Tina's senior. She used to take this class back in the day. It was some of the worst days of her life, but she's made it to the other side. She did it though. Teacher sucks, but aside from that. Shouldn't have been fun.
If only.
It's okay, shouldn't have. It's fine. I'm used to students hating. It's okay. It's fine. Note that for this example, we don't know what C is. Right? So because of that, we're going to have a system of equations with 3 variables, which sucks. Let's check to make sure we got the right equations at least. Because if you don't have the right equations, you're already dead in the water.
What's that?
Real quick, just confirm you guys got the right equations.
Oh, yeah.
Because if you already got messed up equations, it's already over before you start.
Doing race to the wrong.
Oh, here. There you go. Okay, so I'm gonna move this now, guys. Are we okay? I just wanted to check to make sure you at least got each equation,
Yeah.
okay? And I'm gonna label them equations 1, 2, and 3. And this is where, if you don't remember how to do system of equations with 3 variables, again, you can go back to your notes. We did that right here, this problem. So if you are not remembering how to do system of equations with 3 variables, you go back to your notes here, okay? Remember your test is on Tuesday, same. By the way, what variable would y'all cancel?
B,
Huh?
B.
B? Why not C?
Oh, my God.
I mean, you could cancel B, B works, but
I
dude, C's are all just,
Oh, yeah.
They're the same.
Oh.
Just make it negative.
you just need to make one of them, well, whatever, you need, you guys, it'll still work with going B, it'll still work with B, it's just gonna take more work, it's fine, I know, huh? No, don't multiply the C by 0, multiply one of the C's, one of the equations, multiply it by -1.
Right.
And then just keep using that to cancel out the C's in the other 2 equations. I'm probably gonna modify equation 1, because that's probably the easiest.
I'm done. I've only
Yeah,
got,
this is a tedious process.
I've only got C so far.
What did you get for C?
4/3.
I got -4/3. That will mess you up. Double check it.
Oh. Darren, did you get -4/3? What is the?
I don't know, go back and look at your
I
work.
got 2 negatives, I cancel each other out.
I don't know.
No, I didn't. Because I got -216.
Oh, yours is gonna be different.
I don't know, go back and look at your work, but I'm pretty sure it's -4 over
We
here.
can cancel first.
B.
Oh, I canceled C.
I can't see the.
What'd you get for B then?
B is gonna be the last thing I find.
Oh, okay, so what did you get for A?
I was in the process.
Okay, never mind. So C is gonna be, I got -4 over 2
Okay.
for C, so just so you know. I'm pretty sure I checked it, so I'm pretty sure it's right. So I usually do go back and check. But I'm redoing it again, so why not?
Oh.
Found it? So we gotta be super careful. The math is a part, the math is tedious. It's a problem.
Well, supposed to be -4. Oh, I messed up, sorry.
Wait, I got -16/9 for CF.
Yeah, but we simplify then,
Right. Geez.
right? Wait,
I don't think that.
no, yeah. I don't know, I'll post up some more.
I guess, yeah, my original answer was -16/9.
See, we're going to send it myself, why does that?
Honestly.
Okay, so you guys, I'm gonna be posting up my work as I'm going kind of along. The problem is if you didn't go the same route as me, in other words, if you didn't start by canceling C, it's gonna be harder, if your work's not gonna look the same. It's fine, if you do your math right, it should still work out, but this is where I'm at for canceling C. Now I'm gonna cancel B. Wait.
Oh, that's A. Did you get for A?
What?
Did you get for A? -16/45. So it's less than 1.
To do some type of, yes. Sam. When you get When you get. I got supposed to go over.
Nine, 24 is
Um,
16.
I'm not sure about my.
What did you get for A? I can tell you.
12.75.
Can you give me a fraction? But no, I don't think so.
Oh. I can't get that. Well. Yes.
My book. Oh, you said-
Negative. Well, I get 3.75. Oh, how is that? All right, what'd you get for A? What'd you get for
My first A was 48 divided by 180.
That's correct, negative 48 over 180.
-48 over 180.
Yeah. Because that's what I think I'm about to get right now. This stuff. Here, like 216 minus 396. That's going to get negative 188. The B's will cancel out. 72 minus 24 is 48. Right.
Didn't you multiply it all by -4 though? You multiplied the -12 by -4. Or did I just mess up and getting?
I think you just, well, here, I did. I multiplied all this by -4 to get that to be a negative 396. This to be a negative 36. This to be a negative 24. You could choose to multiply this by a negative or this by a negative. I want the smaller number negative.
Well, I guess my equation. Because I didn't cancel it.
Yeah, so yours might be slightly different, but nonetheless, A is supposed to be a negative term.
Maybe I just missed.
Yeah, you probably somewhere down the road, because I mean, I'm looking at this. And I can go back and verify that my answer is right. Now that I have A,
So how would like decimal you be expecting a function instead of a decimal?
if it's a non, so in other words, like if it's a nice clean decimal of 0.36, sure, give me the 0.36, but this fraction, it's not, it's not exact, so in that case, but you know what, you guys, to be honest, I'll take either one. Because if you're using scientific calculators, it's not as easy, you know what I mean? So like, if you give me the decimal, it's fine. I'll take it, I'm not gonna be that good, okay?
How do you do the fraction?
There is an instruction manual, so there's like a stack right there, a little box, right behind that stapler. There's a box, yep, all the instruction manuals, there is a way to do it on your calculator, you just have to go look, because I don't know. Yeah, you could grab one if you want and just take it, hang on to it, or whatever.
Well, that's all. 'cause that's the way.
I'll have them make it. Don't ask me about the spell, but I'm.
I'm sort of trying to.
So far, A is this, B is this, actually,
Should be negative or positive?
positive.
Never mind.
Oh, I'm sorry for nothing. Okay, do that. Yeah.
Oh, I can wait. I didn't know.
And then finally, I just need C. I think I'm gonna use my easiest variation. A plus B plus C equals 2. Probably the easiest one. I'm gonna plug in this for my A, this for my B. You know what C is 2.
Oh, my goodness.
Oh, it is.
I get it. I got it.
So then, final answer, I can go back, I'll double check it to make sure that the final answer is going to be -4/15 x squared plus 18/5x minus 4/3 equals x. Okay, so let me talk you through this, okay?
What?
So again, if you decided to cancel out a different variable other than C, it is possible, you're just doing more work, okay? So the first thing I do, again, I'm lazy, so I always try to do the least amount of work. I really study what I have going on here. I look at my A terms. I'm like, okay, A terms could get canceled. I'd have to multiply this first one by 25 when I go to put these two together. I have to, or -25, sorry. And I'd have to multiply by -100 if I wanted to mess with this. Like, okay, so I have to mess with basically two different equations. Then I looked at these and I was like, all right, that's a 5, that's a 10, that's not too bad. I can multiply this by -5, get the b's to cancel here, multiply this by -10, get that to cancel there. Or I could even possibly work with these two to multiply this by -2, whatever, there's all sorts of ways. I'm like, okay, so that feels like about the same amount of work as A. Then I'm looking at the C's and I'm like, whoa. In general, when I'm looking at a system of equations with 3 variables, my eye is always trying to find a variable that has no leading coefficients. In other words, just a random letter. When I see that, I tend to use those equations because I know it has the least amount of work, let's say, right? So the fact that all of these C's are just C's, I know that if I take one of these equations and just make everything negative, that the C's will cancel out. So I do that, I'm canceling out C, right? So the first thing I do is I'm looking at my all three equations here, and I'm like, this is the easiest one to work with. It has the least amount of steps on it. So why don't I just change the sign of everything? Let's make everything negative, right? Because again, my intent is to cancel C. So I do that. Here it is. So I'm modifying equation 1 by multiplying by -1. By the way, if you're like, what is this M1? That's just me saying modify equation 1. Okay, and again, do I actually do that when I'm doing my own work? No, I'm doing that because you know it's for you guys, okay? So I'm using this modified equation 1, and then I'm simply just using equation 2 as is. 25a plus 5b plus c equals 10. For this one here, I'm just gonna use the regular old equation 3. There it is. I guess I should have written that. That's equation 2. This is equation 3. Add straight down, right? This is gonna be 24a. This is gonna be 4b. This is gonna be 8. The c's canceled out over here. We got the 99a. 9b. 6. Wait, not 6. No, 6. Yeah, what am I doing? 6. That's it. Okay. So are we okay so far following on what I've done here? So even if you didn't choose C, can you at least just understand what happened?
Yeah.
Give me a thumbs up if you get it. Give me to a side if you're still like, huh? Give me a thumbs down if you're like, I do not understand what's going on at all. Okay. So again, you make a decision on what variable you want to cancel and you proceed to do that. Okay. From here, I'm now down to a system of equations with two variables. I've got A's and I've got B's. I'm going to cancel out B's. Does anyone know why I chose B's? They're small numbers. Like that looks easy to me. What's the common factor? The common number, sorry, common multiple. 36. I can make this a 36 and this a 36 pretty easily by multiplying them by the other number, right? But I do have to make one of these negative, okay? So all I did here was rewrite these problems. 24a, 4b plus a, I just did that. This is me transferring over my info here. Remember, I need the cancellation to happen with b's. I know that I can make them both 36. This equation has to be multiplied by 9 to make it be 36b. This one has to be multiplied by 4 to make it 36b, but for cancellation to happen, one of them has to be negative. I chose this one because it's a smaller number, but it doesn't matter. I could have made this one negative instead, okay? So then I proceed to go through, distribute the 9 to everything. This is my brand new modified equation. I do the same thing with this one. Here's my brand new modified equation. Now I'm prepped to cancel out my b's. So I rewrite them vertically so they're stacked. Adding here, 216a minus 396a is negative 180a. Right? It's negative. It's a smaller or bigger number subtracting from a smaller number, right? The b's cancel. 72 minus 24, that's going to be a positive number. So if one of my numbers is negative and the other one's positive, when I'm trying to simplify, that tells me a is going to be negative. Okay, so here's what I end up getting once I simplify. From here, the next variable I should find is b, because I've got two equations here that have b's in them and a's, and I already found a. I went with this one because it just had the smaller number in the beginning, I guess. I just did the math there. I find b. As soon as I find b, I can utilize any of the OG equations or even the modified ones. I decide to just roll with the equation that looked the most straightforward to me, which was the original equation 1. That one looked the easiest. I plugged in my A, I plugged in my B, I gotta figure out C. There's math. How can I go back and double check that this actually is the answer, or that this actually works? Without having an answer key. How could I confirm this is the equation? Yeah, go on.
You can plug in one of the original X's and you should get the Y now.
Yeah, I can plug in. You guys remember these original points we were given? If this equation's good, every single one of these points should check out. When I plug in 1 for X, I better end up with 2 for an answer. When I plug in 5 for X, I better end up with 10. When I plug in 10, I better end up with 8. So let's just check it really quick. The equation is -4 divided by 15, X squared. For my first point, X is 1, plus 18/5. I highly recommend whenever you guys have fractions, that you put the fractions in parentheses, okay? And that's supposed to be multiplied by 1, because it's my x's, minus 4/3. What am I supposed to get? 2, right? I'm doing the first point right now. So I plugged it all in. Let's see what I get. Boom. I got 2. If I'm paranoid, I'm like, oh, I don't know, maybe I should check my next one. Let's check the next one. So if I'm doing the next one, okay, 5, 10, so I'm gonna be plugging in 5 for x, and when everything is said and done, I better get 10 for an answer. So here I go, -4/15 times, the number I'm plugging in is 5 for x squared, plus 18/5 times 5, which is my number for x, minus 4/3. What was the number that it needs to be again? 10. If you're still paranoid, you're like, I don't know, maybe this is the right answer. You can plug in the last point. I'm gonna plug in the last point for good measure. -4/15. 10 is the number that I'm plugging in for x, because that's the coordinate. 18/5. 10 minus 4/3. Again, my answer for this should be 8. So. Now, was anyone weirded out by the coordinates themselves?
Yeah, I dropped it.
And you were like, what is that? What's the odd thing that maybe you noticed? What's the weird coordinate? What's the one that doesn't look like it belongs?
10/8.
10/8, right? Because here it's like smaller x, bigger y, smaller x, bigger y, bigger x, smaller y. What do you think happens at this point in the graph? It starts to decline. It's a quadratic, right? What do we know about this function? Looking at it, well, we know it's a quadratic. It's a negative function, which means it opens down. So apparently at 1, 2, and 5, 10, those points are still going up. But by the time we get to x = 10, it's starting to go down because it's that part of the quadratic. Yeah. You have a question, Sam, or is that just a stretch?
I'm just not really out with my hands.
Okay, just to make you guys, I don't know, feel some sort of way. This originally was the first problem on the test. Originally? Yeah. Yeah. But it's not anymore. Sure. So here, so come on and do that. While we're doing, and then so it looks like Abby will post that up online if y'all need to see it. If you did not get the answer, okay, so here's my suggestion. If you did not get the correct answer, I recommend on your own time, try again. See if you can do it, okay? And you don't have to cancel C first. You can do it whatever way you wanted to do it. Just be slow, be methodical, take your time, okay? All right, so what are we doing today? We just got done with that long warm up. We got a class competition update.
Oh, yeah.
Whoops, I didn't write what the class competition is. Hold on. Let me fix that. Oh, I don't even have the thing for it. Okay. Danish cookie class. Okay. So I know these names are always written. And then we're in chapter 7. Okay. So where are we currently at? Tape bowling. How did y'all do?
Second place.
Yes.
Yes! Third place went to 8. So they did not beat you.
I'm the second.
You guys got second place. But third period was able to pull off the W because they did get further. I want to say they got further by maybe like 3 or 4 feet. Hitting the door is what stopped you guys, right? They didn't hit any doors, they just kind of eventually just ran off. But that was a good roll. That was a good roll. If you guys saw second period's roll was very sad. Barely made it past the small number. And you had 8 was okay. All right, so where are we coming out? So
Last time we were 9.
that's our schedule. Like I said, we might get to 7:10 and 7:12. If we don't, those are extras. I will post the work and the solutions online. But if you don't get to it, I'm not doing any explanations. It is what it is. Do not forget, you have your chapter 7 test on Tuesday. That date is not moving. Book assignment 7 is due, and you will have a video homework assignment, basically, that you need to make sure you watch before the night. Okay? Schedule so far is looking good. I don't think that we're on pace. Like I said, I know we might not get to 7:10 and 7:12 today, but that was never a priority. So most years, The first years I taught the stuff, I never even did 7, 10, and 7, 12. I never even showed them the work. I just didn't do it. Okay, so this is like extra practice. All right, so the class competition for today. Danish cookie toss. I don't know. I'm trying to think of something that was like holiday themed.
Right.
And if you've ever seen one of these tins, right? I mean, they don't look impressive. This is a very large one. I don't know if you guys have the same disappointment that I face every time I see one of these. I always hope that there's gonna be cookies. For me, it's a sewing kit. There's always a sewing kit.
Yeah.
I'm so disappointed. And mine, the one that I have at home is not this large. It's actually circular,
Yeah.
shorter. And it's super weird. It's blue. It's super like weird because like cross-cultural, it doesn't even matter like what ethnicity you are. It seems like people use these for storage devices. And that they tend to be sewing kits, but not always. And it's like weird, but that just happens to be thing. So anyways, I was trying to come up with a competition that has no cookies in it, and like with COVID and everything, it's not considered, all that kind of stuff. So I was like, okay, what do I do? Then I noticed I have a whole bunch of hair ties, my bag, 12 to be exact. So I was like, all right, maybe we should do a little toss where you have to throw it in to make it into the container. So here's the thing. There's 12 total. There's actually 11. I've somehow lost one. So you get to throw one extra one, okay? You have to decide if you want one person to throw all 12, if you want to split it up 6 and 6, if you want to have 3 people go and go 4, or if you want to have 4 people go 3. So the first part is you got to figure out how many people you want to have. The second part is you have to figure out where you want to stand to throw. Because if you stand behind this line and you make it in, it's 1 point. If you stand behind this line and make it in, it's 2 points. If you stand behind this line and you make it, it's 3 points. So you have to, in addition of figuring out how many people are participating, you also got to figure out where you want to stand. And you can do a combo, and you can have it to where you're like, okay, maybe I'll do a couple here, maybe I'll, like, you decide, I don't really care. Just know that you only get 12 tosses and that's it. Okay, so what do you guys want to do?
Let's figure out
5
who
minutes.
wants
Take a
to-
minute to
who
discuss.
wants to shoot.
Yeah, because we
If
can.
you guys
how
wanna
many
do
the other
one
classes
each,
got?
I will forfeit
Yeah.
mine.
Yeah, let's not do one each. I think we should.
If someone makes one, they get to go again. Like Claw Street.
We should make it.
I don't know, you guys gotta figure it out, like,
Let's
a
figure
minute
it out.
or less.
How about-
Figure it out, there you go.
I won't go.
Let's turn the cameras.
Vote for it.
Is this come up here if you wanted to go?
I want to do
You guys should probably do a volunteer.
Thank you.
Okay. You got a top three? All right, so is it just you three? So you guys just wanna go forward?
No, so it's, if you shoot it, you're gonna go.
If you make it, you go.
Yeah, if you make
So
it.
here, I'm just gonna do this, I'm gonna hand you the whole stack, and you, like I said, you can distribute it however you want. Remember,
Wait,
you
can I
guys
see
get
one of them?
one extra, and you don't get to, you don't get to.
Don't put the
grab
entire
this.
thing down.
Are we allowed to? Sorry,
If you want to,
Sim, you can
you
go
get
further.
a total of
You're part
12.
There's an all or nothing.
Wait, you'll lean over the line.
You're in the middle.
You have a reach, you have a reach. You can like do it.
I mean, you could lean, but you can't touch anything, so like you couldn't like hold the whiteboard and go further, like, he has to do it upon his own power. He also can't step past the line forward,
Right.
so, yes, if he like kind of falls forward, it's not gonna count, so he can't do like a, you know, like.
Can you
He
do
falls
that?
after he throws
Like,
it.
you see like
No.
this?
No, that's what I'm saying.
Brandon pulls down.
No, it went down here, from the NBA.
Got it. Very good.
Woo!
Oh, okay.
You just gotta go one minute. Or you keep.
Did he make all 3?
So far we got.
Go for two.
You guys
You're over the
are-
line.
Oh, wait, here, let me give you one extra, here's your 12,
Oh, yeah.
okay? So there's your 12.
Make sure you're not.
But.
Yeah, I'm watching, I'm watching. Okay.
No, over,
Now I'm
underhand,
outside.
underhand. But by the ring like this. I'm gonna sit down.
Hold it on.
I know you're out, you're
Yeah.
so, too much pressure.
Ooh, that was good, that was good.
No, that was, you go here.
Why's my flash on? Hold on. That's embarrassing. No, I see, this is why you don't have your other thing.
Okay, just go for the two, just go for the regular.
Let me get one.
Let me get one too.
I'm gonna do one more.
Okay.
It's a good recording.
I think
Simple, like, two.
So why did you? You're done.
Okay,
I get that.
points on the board.
The one is so easy, the two is like extra hard. Like it looks short, but then when you get up there, it's super long. See? Like it's not even quite as tall.
It's far.
It's far. Hey, if you're going for the two, you might as well go for the three. That's what I'm saying.
Yeah.
You might as well. There's no point in trying for a two.
You want me to just put them on?
Yeah, I have one right away.
Good shot,
Okay.
good shot.
So where are we at? I think you're at 7, but you can confirm 1.
Hello, Tarina.
2, 3, 4.
Hi, Quadro.
That's 6,
I
7.
think someone.
I mean, just so you guys know, when I did this, I just took all of them and threw them, and I got 11. I don't know, but that's
I think that's
me.
the other period.
So. What is?
You should try that, guys.
You guys got 7.
should have put your band, like, and it pulls it along.
Illegal.
No?
So, you guys, you are currently tied for first place.
What?
Ain't no way.
The 8th period has now gone.
I look into the place.
If you get second, technically they get third, right?
There is a thing to
And then that's what
do. Yeah.
Hey, good shooting.
You guys take out your notes, take out your notes.
If there's two first place and then 8th place, that means they get third.
Yeah, if it's a tie for first, I give it.
No.
You guys take out your notes. Real quick, I'm gonna go over 7.4.1, okay? Because you were supposed to, as homework, finish this on your own, and you either did or you didn't. Okay? So we did talk about what you had to do. So I believe when we were in class, we kind of mapped out everything we had to do. We already were given the equation. They want the first part, they want the max height of the ball. Max height is y, right? Will be the y value of coordinate, vertex. And then they want to know when is that height achieved? Remember, when is t or x? So that would be the x coordinate of the vertex. When does the ball hit the ground? Well, we know in general, when we're looking at this, that would occur right there physically, which is an x-intercept, right? Or solution, right? You think of it that way. That happens when y equals 0. And then finally, what's the height of the cliff? We actually already figured that out at the very, very beginning. It was the y-intercept at the start, right? So for the first part A, you just have to take the equation that was given to you, use the axis of symmetry formula. This gives you the x coordinate of the vertex, right? This tells you the time of the maximum height. So we actually already figured out part B. To figure out part A though, which is what we need to figure out, we need to take this answer for x and we need to plug it back into the original equation so that it will give us the actual max height, which is 36 feet. Okay, we already figured out part B because again, we use the axis of symmetry formula that gives the x coordinate of the vertex. For part C, it says taking the equation, setting it equal to 0. Doing that indicates we need to use the quadratic formula. So we do that, we get two solutions, we cross out the negative one, we go with the positive one because that other solution, the other way of thinking about it, if I extend this quadratic, that's my other solution. But again, I don't care because that's past work that's behind us, basically, right? I care about this part right there. So you should have gotten 3.82 seconds. And we already knew that the cliff is 50 feet of high because we started with class. So you guys have this next question, 7.4.2. Please make sure that is in your notes. And make a list of what you're finding. 7.4.2, what I know. There's a typo, I think, on your version. It says impose a coordinate system as pictured, I think, above. I think it said the word above. It didn't say the word below. So the picture's below. So right here, you guys want to cross that out as the word below. Because I think for you guys it's above. Okay. Again, we're making a list of what we know and what we're finding. I'm gonna do it kind of weird. I'm gonna write what I'm finding or what I know right here. Start with that. I'll make a list of what I'm finding right now. You guys are making your own list, things that you know. You guys are making a list of what you know. We'll go ahead and get going. So Tina, where are we at? Are we sure on Coco too?
There's no more under there.
Okay.
Just checking.
Okay. There isn't any under there? Okay. Okay, so then if you could let me know how much I'm short by, and real quick, just to check. Is this, so, the campaign number that you're giving me, oh, no, it's not, okay, so you're actually breaking it down.
Yes, this is not. I finished off all the way.
Yeah.
Orange.
Which is pretty short. So if you could remember that, or even maybe on the bag with a Sharpie, just write Coco 3-dyed short or sticky note, or however you want to, maybe do a sticky note. Just writing it on there, so that kind of reminds us. And then if you could just do a total of like how much we need to buy, then I'll be fine. Okay, guys, so what are some things that I know in this problem? First off, let's start with, how is this problem different than the previous one? Yeah, what's something that you're noticing?
The, like, level of the land is not,
It's not level,
yeah, it's not.
right? Which is possible, land isn't always flat, right? What's something else you notice is different with this again? Okay, we are given the equation in standard form. We were actually on the last one too. They gave it to us in standard form. But the difference here is I don't have a third term, which is different, but I do, what is it? It's 0, so that means we're actually starting from the ground. That makes sense, right? Okay, cool. Yes.
So on the other one, the lab or the quadratic, the row, and this one, quadratic.
Or like the path. The path that the balloon is taking, right? Okay, cool. So now, what are some things that I know? What are some things that are given to me? I think the best thing is given to me now.
The slope of the line.
Okay, so you figured that out, which is cool. I'm gonna go with something else more basic that's given to me. Let's go with the equation, right? Someone was kind enough to create the equation for me that models the path of the balloon.
Why don't you make it just like 1 over, -1 half of.
Yeah, I don't know. Sometimes you does like it versus. Sometimes they don't simplify their stuff and it drives me a little nuts. But anyway, it's fine. Okay, so there's that, and that's true, like, why didn't they? And again, you might want to note that this equation is the balloon's path. It's the balloon's path. That's what this models, which again, is a problem, right? Then I'm gonna go with who, Sam, you gave me this info, you think it's gonna shut off? I don't know. You gave me the ground slope. They tell you the land rises at a constant. I mean, when I see rises at a constant, that tells me linear, right? And that makes sense because that was the line, right? It raises at a rate of 2 vertical feet for each horizontal foot, or 20 horizontal feet, right? So it's basically, ground slope is 2/20, but because we believe in simplifying here, it's gonna be 1/10. Okay? So we actually have the equation of our line. That one, what's the equation of line? Plus 0, right? Because that y-intercept is also 0. So that's actually the equation of our line. So we could say the equation of round, which happens to be the shape of a line, right? And this one is the balloon's path, which happens to be the shape of a quadratic, right? By the way, why quadratic? Why is quadratic so important? Anything, for the most part, follows the path of a quadratic when it's a trajectory item. When you kick a ball, let's say, it doesn't go straight up and then fall straight down, right? It follows this arc pattern. That's what the quadratic model is, right? It doesn't have this like weird thing where it just goes in the air, hits some invisible force field and just drops straight down, right? Again, maybe unless you're hitting a wall or something, but even when you're hitting a wall, it's at least gonna have the first part of a quadratic, right? And then potentially take the same arc. I guess it just kind of depends on a lot of various factors, right? But nonetheless, it's going to have this curve going on, okay? Anything else that we know? I would say no, there's nothing else. That was it. That was given to us, right? We then automatically jump into all the crap we gotta find. Okay, so let's do that. So what are some things we gotta find? What am I finding? I'm gonna make this list over here. What I'm finding. And as I go, I'm just gonna call everything apart. Yes,
You want me to go?
sure.
Finding the height of the lake.
Max height of balloon. Yeah, we'll get to that here in a second. Max height of balloon above lake. Okay. And then Sam has already decontextualized and said, hey, isn't that technically just the y coordinate of vertex? And you want to be specific there. And you guys, if you're like, shoot, then why are you not using like the whole page? I'm gonna actually start doing my work. I'm actually gonna split my page right here and have what I'm doing on the left, like in words, and I'm actually gonna do my work on the right. You don't have to do your notes that way. I'm just letting you know in advance that's what I'm doing. Okay? So I'm basically gonna be splitting this page in half. I'm gonna be writing all the things that I gotta do right here and that's doing. Okay, so let's keep going with our checklist. Okay, so part B, what's the next thing I'm told to do? So I gotta find the maximum height of the balloon, then what? Max height of balloon above the ground. This is not as straightforward. Okay, so let's talk about real quick. First off, let's talk about where is that? Like where, I guess, where is that visually? Programming with you first.
So like, the vertex,
Uh-huh,
like draw like straight down.
right there. So there, right? So this is actually what I'm finding for part B. Right? Yes.
And then when you plug in the X, the vertex to the line and then subtract the Y.
So repeat what you just said, because like, I'll be honest, I wasn't really listening.
When you, so you plug in the X of the vertex into the line equation and you would subtract the two Y's. Okay? You get the distance.
Let's see what that, so first off, he's using, right, he's saying, to find the y coordinate of the vertex, we have to find the x value for the vertex. Okay? That's actually the first part, right? He's saying, take that x value, plug it into the lines equation. Why would you do that?
Because they both sort of.
And they're both gonna have the same x, right? At this point, they're gonna have the same x coordinate. So when you plug in that x, what does that technically give you? The y, the height right here, right? So it's gonna give you technically that height right there, right? So to find B, to find this one, I'm gonna draw this. I'm gonna say, it did say to impose a coordinate system, okay? So I'm gonna call this my x-axis right here, and I'm gonna call this my y-axis right here. There's me imposing my coordinate system. So how do I find B? What were you suggesting?
Since it says the max height above the ground, you just subtract the two y's.
The two y's from each other, would that do it?
The first one, or the
This-
vertex.
So let's do a hypothetical, let's say this is 5, let's say that's 20, right? So that would be 15, so yeah, in theory, we could do that. Another thing we could have done was figure out what this pole height is. Oh, but wait a second. I just thought of something that we didn't think about. The vertex. Okay, so, yeah, no, what you're saying is right. When we figured out the vertex here, don't forget that that's this whole line right there. Right, not to the ground, to the like ground underneath the ground, I don't know what you want to call that. First step of purgatory, I don't know. Okay, whatever that is, I don't know what that is. Magma, I don't know, right there, right? So when we find this Y, we actually find this whole thing, so hold on. Yeah, that's the max height of the lake, no, so that's right, so this, let me do this, just so it's not super confusing. Let's call this part A, because that's part A, the whole length, this whole thing right here, that's part A. And then part B is figuring this out. So yeah, you could take this and subtract this. Or what you could do is, I mean, I guess it's the same thought process. Taking, it's that, addition segment postulate, where this piece is basically the whole minus one part.
Oh,
It's the same thing, Sam, it's what you were saying. Because what you're basically doing is, you're taking the whole length and you're subtracting this little guy.
Yeah.
Which is what, I mean, that is what we're doing. Okay, so that's right, good. So let's make a note of what we're physically doing mathematically speaking. We are gonna subtract y from round. Subtract y from round. From y from balloon.
That's.
I was gonna write quadratic, but we could have also worded this by saying subtract y from line, from y from quadratic. I mean, it depends on how you wanna word it, okay? But then I have a little note here. It says, then after simplifying, use axis of symmetry to find adjusted vertex. So let me mold this over real quick. So laying ground, here's that. That's gonna give us our x coordinate. Because, let's see. Mold this over my mind. We'll right back. Then after simplifying. Let me put myself back in this mind space real quick. While I'm doing that, talk about what the next parts are with people around you, part C and part D, because there is a part C and a part D. Let's see what happens with parking, because I actually went about it a slightly different way. Okay. So I know, I can see what I did. Instead of me subtracting y from the ground y from the balloon y, I actually took the equation and used those instead. To find the x, and then once I found the x, then I used the x and plug that in. So we'll see if this works. We'll see if Sam's method works. In theory, it sounds like it should. So part C, what's the next thing we have to find? Part C.
where is the balloon land?
The next one is where does balloon land on ground? Where does balloon land on ground? Okay, and technically in our picture, it's gonna be right here. That's C. Okay, like we're visually going, well, what is C? C's right there, right? And then what is this in mathematical terms? What am I actually finding? What is that? Like when we're thinking about the math involved, what do I need to actually do to answer that question?
I see. Find the intersection point by saying.
find intersection of balloon and ground. That's the basics, and then I like how Sam took it one step further. How do you find the intersection? By setting both equations equal to each other.
What's my brain this problem?
Find intersection of balloon and ground by setting both equations equal to each other. And solve for x. And is that it?
And we plug in for what?
That will technically find when they intersect, right? Like, what time they do. So then I need to take that, then plug x into what?
Middle line.
Either equation. For the height. Right? Because again, if you remember, what is x? This is the time. If I set both equations equal to each other, finding the time, which is cool, I'll know when they intersect, but that's not what this problem is asking. This says, where does the balloon end? So that actually wants to know, right? That, okay, and then last question. Part B. Last thing I'm doing.
Where's the balloon?
Where is the balloon? 50 feet above. Yeah. That's what that's the question I have to solve, but how do I go about doing that with the math? Oh,
Once you set the equation that it gives you the problem equal to 50,
yes, which equation? There's two.
the -2 over 2,500 x squared plus 4/5 x. Because isn't that the path of the balloon?
Let's see. Where is it above the ground? So add 50 to ground equation set equal to quad. Solve for x and put y. So I actually wrote down, you want to add 50 to the ground equation because the ground equation now is going to be, and then set equation equal to quadratic, solve for x, then plug y in for either equation. So let's think about this one. Where is the balloon 50 feet above the ground? You don't want to just slap the 50 at the end of the quadratic because now you're changing the equation, right? Like that equation models the path of the balloon. If you put a 50 on it, you're saying, oh, we have a y-intercept of 50, we're starting at 50, right? So what you do is you add 50, right, what we're actually doing, add 50 to ground equation. Because we've got our ground equation, and what we're saying is, no, go 50 above that. Go 50 above that. We're not adding it to the quadratic equation, because we're not wanting to go 50 above the quadratic path. We want to go 50 above the ground, okay? So add 50 to ground equation. Set equal to quadratic equation. Solve for x. Again, that will tell you when you are 50 feet above the ground. And then you have to plug that value in for y to actually figure out y. And again, I'm going to reiterate, you guys, why can't we put the 50 on the quadratic equation? Because remember, the quadratic, right? This equation uses this, right, as its base. If we're trying to go 50 above the ground, this is the ground, right? We gotta go 50 above the ground, not above the x-axis. If you add 50 to the quadratic, you're adding it to the magma level, whatever that is. Does that make sense? Okay, so what's your question?
Would it be possible? Would it even make sense if you somehow like, you put the slope in as like the new C for the quadratic equation?
You plug in the C for the quadratic. No, because remember what C represents. C represents the y-intercept. So this is another reason why you can't just put 50 in the quadratic equation. Because you're then now saying that this starts at 50. This whole thing starts at 50.
What if I said it's over that 1/10, that's like the slope of the line?
So you move that whole thing up at 150, and then the slope of the line. I don't know. I'll figure that one out. Okay, so I'm hoping you guys can understand why the 50 has to go to the ground. You're saying 50 above the ground. Okay, so why would you do that? So let's actually start to do this. You don't have too much time. So for part A, max height of balloon above lake, it's the y coordinate of the vertex. That's easy. You guys should be able to do that. Go ahead and do it. If you need help, you can look, but basically you utilize that axis symmetry formula. I'm rewriting the equation just because I don't know. A, B, who remembers the axis of symmetry formula? Negative B over 2A. That's the formula, right? Remember that this is going to give you the x coordinate of the vertex. We don't want the x coordinate, we want the y, but we need the x coordinate to find the y. Okay, so do your thing. I'm going to make this line more aggressive. That actually be a nice number. I actually took the time to review all the math, so maybe I'll do that, even though I did not have to do this at all. It's a complex fraction. So remember, you can multiply by the reciprocal on the bottom, whatever you do at the bottom, you do the top. Those cancel out. Because either way, it turns into 500. That, like I said, is the x coordinate though. We need the y coordinate. So how do we find the y coordinate again? Plug it back into the original for x. We're going to do 500 squared first. Then multiply that by. That turns into 400. I guess all in. 200 people. So once you guys have that information, you could always go back and write it. That the vertex, this right here, this vertex is 500 on 200. And again, remember that that calculates the whole length A, the whole length A, all the way down here. Remember, this was imposed our coordinate system. Okay, this is not drawn to scale. Just use word. Okay, use the word. This is not drawn to scale. All right, so it's part A. Part B, I'll let you guys figure that out. I'm gonna be curious. I'm gonna use Sam's way for now, see what happens, and then if that doesn't work, we'll talk about what we need to do.
from B, we're trying to find the Y of the ground now.
Whatever it says here, read through it real quick.
Oh,
That's why we took the time.
I know, it says subtract Y from the.
Where are you?
Y from the ground.
Huh?
You don't know what's going on.
Okay. No offense, part A is like, hey, it should have been pretty straightforward. Okay. Like, the max, we're trying to find the max height of the balloon over the lake. Hopefully you realize this squiggly is the lake. Right? The lake is a zero, right, at zero. So if we're trying to find the height of the balloon from lake level, like just this vertical height here, the maximum height is gonna be at the vertex.
Yeah.
Okay,
Right.
so I use the axis of symmetry, which is gonna give me the x coordinate of the vertex. But again, x coordinate just tells me how far to the right it's moving, right? What I need to know is the height. How do I find the height? By plugging in into the y coordinate or the x coordinate of the equation. That gives me the y,
Yeah,
because that always does. So where did you go?
get everything else.
Okay, so now let's talk about the next part. Thank you for having me go over something you already understood. So I'm gonna let that sit for a minute, because I'm still working through it, so. Part B. Part B. It's not as simple as just 150. So, no, and so let me kind of think about in my mind why it's not. So that is the height from the vertex to this invisible ground here, right? If I plug in y, if I plug in the corresponding x to this, it gives me this height. And they want to know from the height. Oh, that's why. That's why. Okay, this is why. Just occurred to me, max height. For part A, the max height we're talking about, right? From the lake is the vertex, right? But what's not to say that the maximum height of the ground and the vertex is the biggest height? Okay, I'm gonna draw a really skewed photo here to prove my point. So, right, here's our vertex. Okay, so here's kind of a rough sketch of what we originally had going, trying to find this as level as possible. And we got the ground here, right? This is the vertex. If we're asking for the max height of the lake, by the way, this is all lake level, right? For part A, it is as simple as just saying it's the Y, okay? But for part B, they want to know the max height from the balloon to the ground. But this line is no longer flat. I'm assuming that the maximum height is at the vertex, but the ground keeps climbing. What if the maximum height is actually right here? Because the ground drops lower. I'm going to draw you a super skewed version of what I'm talking about. So what's not to say? Hold on, I'll start me. Hold on. Okay, so here's a picture that kind of demonstrates. Vertex is right here, right? I think this is a length right here, right? I think this line looks longer than this one here. We're now assuming that this is the maximum height, when in actuality, in this skewed picture that I drew to try to prove my point, it's not.
Yeah.
The maximum height, if you see, this is a longer length than this. Okay? So what I'm saying is we can't make the assumption that it's as simple as just going, oh, take this length minus this, or take this length minus this one, and that's it. Because maybe the longer distance might be to the left or to the right, just because we don't have flat land here, right? We have a slope here. I drew a really skewed photo to show you, a picture to show you where clearly the vertex isn't the longer height. It's this to the left of it. In this picture, we don't know for certain. So the way to actually do this, okay, max height of balloon above ground, we're going to actually, and I don't know why I didn't just write this, subtract ground equation. Ground equation from quadratic equation. Because by doing that, right? So when we do that, we're going to actually be finding the maximum distance. When we did it the other way, we were assuming that at the vertex and the ground, that that's where the maximum height could be, but it could be to the left of the vertex and it could be to the right of the vertex, right? So the way to check for sure is to subtract ground equation from quadratic equation. I'm gonna make a little side note over here. Then, after simplifying, I don't know how to read, use axis of symmetry to find adjusted vertex. And I say adjusted vertex because that's gonna be the new, where the maximum is or whatever. So let me walk you through it off to the side. We're gonna take the quadratic equation and we're gonna subtract it from the line equation. The quadratic equation is -2, 2,500 x squared plus 4/5x, that's that equation, minus the line equation. The line equation was
110.
110x, okay? And we're gonna set it equal to 0. Because we're trying to find, again, where they intersect at 0, right? So when I do that, I'm now gonna have a different looking quadratic. It's not gonna be too much different. The first term is still this -2/2,500, but my second term is now gonna be a little different, right? This is gonna be, I'll just tell you the number, 7/10x. So combining these two terms is gonna turn into 7/10x. And it's all gonna equal 0. Now from here, this is now gonna calculate the maximum height from the ground, because this is what I'm doing, I'm factoring in the ground now. I'm not using that lake level, okay? So now that I have this, I use my axis of symmetry. And whatever that is, that's gonna be my next coordinate. As soon as I find that, I plug it in to find the y coordinate. Okay, I'm gonna tell you guys, I'm gonna continue doing the work here. So off to the side here, this is gonna be -b all over 2a. Because that's the axis of symmetry formula, right? So then from here, this is gonna turn into -4. So you guys, I will go ahead and make a recording of parts B, C, and D. I will post that up online some point today. And you guys can check it out for yourself, okay? Again, if something is still confusing to you on this, maybe you need to ask for help in the discussion board. You need to have to sit down, maybe you need to come by and see me after school on Monday, maybe today after school, okay? It's on to do that. I will post up this to 7:10 and 7:10.
Okay, bye Trina.
I FaceTime Karina and,
Bye. Thank you.
No problem.